One of the greatest events in amateur radio occurred in December 1921. In fact, it was a great event or breakthrough for all radio communication. It made the headlines of many newspapers and magazines such as the Scientific American. Now, let us review radio as it was prior to 1921. Amateur activity was resumed in late 1919 when the World War I ban was lifted. Most amateurs following the war were still using the crystal set type of receiver with the galena detector and the familiar cat's whisker. And for the transmitter, they had the low-power spark coil type of transmitter. DXO maybe 10 or 15 miles under favorable conditions. By 1921, however, the advanced amateur was using tube-type receivers. Here is ARRL President Hiram Percy Maxim with a regenerative receiver at his home station 1AW. Let us have a closer look at a modern 1921 station. Here one can see the regenerative detector receiver with honeycomb coils and the 1 or 2 stages of audio. At the right is a long-wave monitoring receiver. Yes, the amateur used to listen to long-wave ship and shore stations, since there were but very few broadcast stations in 1921. At the right foreground is the all-powerful 1,000-watt rotary gap spark transmitter. Average DX, 5 to 800 miles. Note the huge flat-strip copper inductances. Wavelength, somewhere between 2 to 300 meters. This was the ultimate for the amateur in 1921. Let us listen to it. And what were the commercial stations using at this time? They either had spark or arc or a few low-power tube transmitters and possibly the newly developed Alexanderson alternator transmitter. RCA built a huge transmitting station at Rocky Point near the end of Long Island, which to use this new type of Alexanderson alternator. The Rocky Point antenna system was to be a series of antennas in the form of a cartwheel. Each antenna would be 400 feet high and 1 mile in length, pointing to different parts of the world. This is a sketch of what one of them would have looked like. Other large commercial installations were still using the vertical type of antenna. This is a 900-foot one. It was agreed at this time, more or less by the engineers, that the longer the wavelength, the greater the distance. The short wavelengths supposedly had very little value. The multiple tune type of antenna required several tuning houses. And this is an Alexanderson alternator, a giant motor driving an unusually designed alternator whose output was in the radio frequency range. A masterpiece of the electromechanical engineering. These two alternators are each capable of 200 kilowatts of RF output. We've now seen what the amateur was like in 1921 and the equipment used by the commercial interests for transatlantic communication. The amateur had been allocated the low, inferior wavelength of 200 meters, while the commercials were given the long wavelengths up to 10,000 meters for DX. Now let us pause for a moment. The stage is now set for the 1921 tests. The radio amateur had always been fascinated with great DX, and spanning the Atlantic would be the ultimate. The ARRL initiated a series of tests in December 1921, when selected American amateurs would transmit predetermined code letters to be received, hopefully, by European amateurs. One of the leading stations in the test was one operated by members of a New York City club, the Radio Club of America. One of their members volunteered the use of his station in nearby Greenwich, Connecticut. It was a small building with a 75-foot mast. And since they wanted to use a large flat-top type of antenna fed in the center, they moved the building over into the center of the field. Members of the club are all businessmen or radio engineers who took time off from their work to construct a new type of antenna and transmitter. It was group effort and everyone pitched in. And much to their dismay, it started to snow before they could finish the antenna. It consisted of 8 wires in a form of an 18-inch diameter cage. The vertical section was also a multi-wire cage. One of the leading participants was none other than Major Armstrong, the inventor of the superheterodyne and later FM. Let us read about their adventures. The antenna was commonly known as the T-type. One end was held by a new 100-foot mast, while the other by the original 75-foot pole at the edge of the lot. Both the vertical and horizontal sections radiated. The system worked against an elaborate radial system. Much credit must be given to these early amateurs for their use of such an efficient antenna. Their antenna could easily compete with any elaborate present-day 160-meter antenna. A close-up of the wires going into the radio shack. The vertical antenna feed is in the foreground, with the radials in the rear. And just a reminder, this entire system, including moving the building, erecting the 108-foot mast, was all done in a matter of a few days. A nice view of the completed station. And here are the 5 fellows who undertook the project. Left to right, we have Ernest Amy, John Grinan, a crack operator, George Burghard, Major Armstrong, and Minton Cronkhite, who is the owner of the property and the holder of the station call that they used, 1 BCG. This is a general view of the transmitter. At lower right is the 2000-volt ESCO motor generator set, which provided the plate voltage. The antenna tuning system is at the upper left on the ceiling. Their objective, of course, was to tune for maximum current in the antenna. They attain 6.5 amperes at 990 watts input. They were not without their problems, however. Let us read. And this is the transmitter circuit. A single UV204 tube, which is a 250 watt oscillator, is driving 3 similar tubes in parallel as RF amplifier. They encountered great difficulty in stabilizing the circuit, since this was before neutralization and the amplifier tended to oscillate. A greater problem was in keying. The only way they could prevent chirping and the amplifier from breaking into oscillation was to key the amplifier grid circuit and the oscillator simultaneously. Oscillator keying gave a chirpy note, so they mounted a 3-turn coil in the oscillator tank circuit. Note the relay K1 and K2. When the key was up, the amplifier was off, and the oscillator was on a different wavelength. When the key was down, the 3-turn coil was out of the circuit and the oscillator was on the correct wavelength, and the grid circuit in the amplifier was connected. In other words, the oscillator remained on at all times. Rather tricky, isn't it? Here is a close-up. It was hurriedly assembled. Note there was no separation or shielding between the oscillator and amplifier circuits. And strange to believe, this could have been the most modern and the most powerful amateur transmitter in the country. And as you will see, it proved to be exactly that. You may wonder about the tubes. This is a display in the AWA Museum showing the development of the UV204. It was the first high-power transmitting tube made in America. Developed during World War I, it was first called the P-tube. It was given the number 204 in 1921 and is the 3rd tube down from the top. Here are the receivers at 1 VCG. Note the storage batteries under the table to light the filaments. By the way, the only source of heat in this small building was a small kerosene stove. A closer view. The receiver was the best at the time, an Adams Morgan RA-10. A Magnavox horn speaker is at right, and one can see a pair of Baldwin headphones on the table. The receiver at upper left with the honeycomb coils was used to tune in the long-wave commercial station at New Brunswick, which sent out the reports and the results of the tests. A closer look at the receiver. As customary for the time, the tuning unit was in one cabinet and the detector and audio stages in another. The tuner, in this case, was the RA-10, and the detector and audio unit known as the DA-2. Here is an RA-10 in the AWA Museum. The set is greatly sought by the radio collector. Of interest, the circuit was designed by Paul Godley, whom we will hear more of later. A close-up. The set worked well on both CW as well as on spark signals. The tuning range, I believe, was somewhere between 150 to 700 meters. The set used the new UV201 tubes recently issued by RCA. Each tube drew 1 ampere on the filament. This was later reduced to a 1/4 ampere and became the UV201A. We're now ready for the test. Nearly 30 American and Canadian amateurs were waiting for the big day when they were to send coded signals. Who would be the first ever to send a message across the Atlantic Ocean? To ensure success and to back up the British and other European amateurs listening in, the ARRL sent an American amateur to England with the latest American receiving equipment. The amateur selected was the popular Paul Godley, 2ZE, from Montclair, New Jersey. Godley was a well-known set designer and DXer. Initially, Godley was going to set up his receiving equipment in England, but due to local QRM, moved to Scotland, where he set it up in this tent. Following the instructions of Harold Beveridge of RCA, he and his assistant erected a 1,300-foot length antenna pointed toward North America. The antenna averaged 12 feet off the ground and was terminated at the far end with a 400-ohm resistor. This was, and still is, the famous Beveridge antenna, still used by many amateurs for 80 and 160-meter operation. Godley used the regenerative RA-10 receiver plus the ultimate for the time, the newly designed superheterodyne. This is the superhet circuit. All triodes, since it was before the multi-element tube with high gain. Note the many resistance-coupled IF stages instead of transformers. The superheterodyne was designed and invented by Major Armstrong. This is an early IF amplifier and detector on display at the AWA Museum. It was personally made by Major Armstrong and may be the oldest of its kind in existence. A close-up of this rare historical piece of equipment. Of passing interest, a small, modern, solid-state IC chip the size of one's fingernail would have far more gain than this 4-foot unit. Godley kept a log of all reception under the most trying conditions in the wind-blown tent. While back in America, 1BCG and others were sending and hoping Godley would receive their signals. In time, Godley not only received 1BCG, but several other stations, including several using spark transmitters. The Atlantic had been conquered. And then came the big moment. 1BCG sent a complete message, preamble, text, and signature, which was received solid by Godley, the first complete message ever sent and received across the Atlantic. Ironically, the verification of the reception was sent by the huge RCA 200,000-watt long-wave station in New Jersey, which I had shown earlier. The test proved that it was no longer necessary to use high power on long waves to span the Atlantic. QST headline the news. Note the call letters 2BML at Riverhead. BML was Dr. Harold Beveridge, the designer of the Beveridge antenna used so successfully by Godley. I took this picture of Harold several years ago on a visit to RCA Riverhead. The accomplishment made news headlines. But first, maybe I'd better tell you something. If you think 1BCG and others were on shortwave as we know it, you're wrong. Any wavelength under 500 meters in those days was shortwave. All the transmissions from 1BCG were on 230 meters, the same as our AM broadcast band. Others also operated around 200 meters. There was no 80 or 160 meter band at that time. 1BCG was the most consistent station heard and the only one to send a complete message. However, as I said before, there were others that got across, some running far less power and, as noted earlier, using spark transmitters. The newspapers gave it a great play. It was the beginning of a new era in communication. It was a signal to abandon the long ways and go to the shorter wavelengths for distant communication. The ARRL, which initiated the tests, had their representative Paul Godley write a complete report. And the local newspaper in Greenwich, Connecticut gave their native son much credit for his outstanding station. The commercial world was awakened to the great possibilities of great distances on shortwave. David Sarnoff of RCA and others came to investigate. The 6 amateurs proudly show their amateur station to the professional radio engineers. It was most fortunate that a commercial photographer was present to take this picture. At far left is the famous Professor Michael Tupin, well-known inventor, physicist, and Armstrong's mentor. In 1950, members of the Radio Club of America erected a memorial on the site of 1BCG to commemorate the great event. The monument can be seen today near the intersection of Clapboard Ridge Road and North Street in East Greenwich. It is within 200 feet of the original station site. It could well be the only monument ever erected to an amateur radio station. It is believed 1BCG was the world's first high-power, modern amateur radio station. Commercial interests slowly abandoned their long-wave stations for ones of higher frequencies. And among them was a high-power, long-wave station mentioned earlier at New Brunswick. I was most fortunate to have known Paul Godley. Some years ago, he made a recording telling of his hearing 1BCG in December 1921. Let us listen to it.
BCG? I know nothing about 1 BCG. Or maybe I'd better say I knew nothing about it until later. Well, anyway, here's my story on it. Most people will remember that in 1921, the American Radio Relay League chose me as official receiving operator to go to the British Isles and listen for signals from American amateurs during those epical transatlantic tests. As it happens, the first signal I heard in Scotland from an American amateur station was one which, oddly enough, was sending the letters PF, PF, PF over and over again. Now that happened to be my own personal sign, as a telegrapher would say. And then, to my astonishment, came, "Hello, Paul," and the code number 73, which of course means best wishes. And that was followed by the call letters 1 BCG.
And that was part of the interview with Paul Godley. This is the last picture I took of Paul, who is at left. Next is Bill Halligan of Hallicrafters, then Harry Houck of the 1 BCG Memorial Committee. The lady is my wife. Paul died in October 1973. And so ends my little story of a great event in amateur radio. What followed? Spark transmitters went off the air the following year, and amateurs were soon operating below 100 meters. So long, everyone.